Okay, I'll start now.
Excuse me, sir.
Yes, please.
Sir, in the last class you told that for one instruction, the program, the compiler has to fetch 2 times from the RAM. I mean, RAM has to be accessed 2 times for
Yes.
one instruction execution.
Yes.
Sir,
Yes.
first time it is searching the page table from page table base register and returning the address of instruction, that is frame address. And second time, it is returned to CPU. And again in second time, the RAM is, the instruction is fetched from the RAM. So 2 times, right?
That is correct. Okay. So last class we studied that why the TLB is required. What is the necessity of TLB? Please tell me, help me. Because it is a high-speed cache and the memory access time will be faster. In case of normal paging, since every instruction needs 2 times memory fetching, but in this case, for the first page, first one, it has to be fetched. From next onwards, it should not fetch it. Okay. I hope. Okay. If I ask this, assume that can you do one small program, whether I have done or not? Suppose there is a. We have done, I think, 21 into 9. Okay. Suppose there is a page having 10 lines. Okay. Page having 10 lines and a program having 13 lines program. Okay. Page having 10 lines and this is a 13 lines program and the whole 13 lines program are in a continuous manner and there is no looping involved. And memory access time is same, let's take 20 milliseconds and TLB access time is 3 milliseconds. Okay, so what I told that there will be a 13 instruction program, 13 instructions program. Yes, and one page size is equal to 10 instruction or 10 lines or 10 bytes, you can say. And your memory access time is 20 milliseconds. Mem access time is equal to 20 milliseconds, and TLB access time is equal to what? 3 milliseconds. 3 milliseconds. Okay. Can you please find out what is the total time required to execute this 13 instructions if the 13 instructions are in a contiguous manner? अब बहुत पीछे हो, नहीं है पास में, आगे बैठ पाओगे if you don't mind. क्योंकि यहाँ एटलीस्ट दिखाई देगा, वहां पर दिखाई नहीं देगा. दो फर्स्ट 2 मिनट से ज्यादा लग रहा है मतलब हम पढ़े नहीं. There are total 13 instructions. Okay, one page size is 10 lines. 10 lines means 10 instructions, and memory access time is this, and the TLB access time is 3 milliseconds. Then what should be the total access time? How much time it is?
39 milliseconds.
339. 339. I also don't know. I have to calculate. Just approach you, make it ready. Done? Anybody from offline? Yes, please.
Sir, 559.
559. Somebody is saying 559. Huh? 369. 339 means first one. This one you are saying. Okay. Okay. At least you have write down the formula for this. Total may not be a big issue. Okay. So what happens now? If you can look into it carefully, I have how many pages required here?
2.
2. Very nice. 2 pages I require. So this has a 10 lines and this has a 3 lines. Yes or no? So when the first line of this page will be fetched, is it present in the TLB? Nothing. So how much time it is required? So it is required 20 plus 20 plus 1. That is become 41.
Plus 3, TLB access is 3.
Okay, 3. So this has become 43. Yes. Rest 9 lines of the same page. How much it is required? Very 20 plus 3, that is 23 into 9. So 43 plus 23 into 9, whatever comes. When it access this particular page first line, is this page currently present in the TLB? No. So for this also how much time? 43. And for these 2 lines, how much it is? 23 into 2. Got it? No? So whatever comes, that's the basic idea. Whatever, that is a total calculation. Now hopefully you understand how it is working. What's the purpose of this? Now we'll go back to the next paging once again. Please carefully listen. Even if the TLB says your memory access time is faster now, because for every instruction he is searching the page mostly from the page rather than from the TLB rather than from the memory, but still my page size is too large. What is the page size? Last class we calculated in the normal computers, almost 3 MB. Last time, if you can think it, if there is a 300 programs are running, then almost 1000 MB means 1 GB page size is stored there. So can you reduce this page? Because once GB page, if it is stored in the RAM, it is very huge. Then how can you reduce it? Yes. So yes. Many spaces. That is also one thing. Many pages that is not used. That is one criteria. Even if all pages are used, assume that the whole 4 GB address space are going to be used. Then I have to use a 3 MB page table or not? How can you reduce this 3 MB page table to a smaller size? That's the target. So that my access time, the TLB says that it will be faster. Along with this, if I can reduce the page size, then it will be better. Okay, so reducing the page size, the next technique they are saying, it is called as a multi-level paging or hierarchical paging.
So it is reducing the page table
size.
Page table size is being reduced.
Page table size is indirectly reduced. How it is, you can come to that one. Okay, how the page table size whole thing gets reduced. But the target is what? When you bring a page table, the whole page table has to be come to the RAM. Now our idea is that can you some part of the page table you can bring it to the RAM, so that among this 3 MB page table we can only fetch a few part of the page table rather than the whole page table, because I cannot reduce the page table size ultimately. What's the reason? The reason says that the paging directly says that every page has to be mapped with a frame. If every page map with a frame, directly or indirectly, I have to keep this mapping information from the page number to the frame number in some table. And the minimum size is 3 MB. There is no way to reduce it. Rather, what I want, I can bring some part of the page table to the RAM rather than the whole 3 MB has to come to the RAM. In that way, I can reduce it. Okay, so that can be done by a multi-level paging, or it is also called as hierarchical paging. Very important. In this, we'll do many numericals, hierarchical paging. I brought 6 to 7 get questions today. I plan for solving this if you can able to do it. Yes. So the multi-level page and hierarchical paging. So I'll give a small example. Please look into it. Let's take my logical address space. Please, everybody concentrate. The logical address space is 7 bits or 8 bits, no problem, 8 bits. Then what is the address space size? Quick.
2 to the power 8.
2 to the power 8. ऐसा no? 8 bit का अगर logical address होगा, मतलब each line will be identified by what? 8 bit. Similarly, कितना lines होगा? 2 to the power 8 lines. 2 to the power 8 lines means 256 bytes is my logical address space. समझ में आ गया? And what it does? This page size is 8 lines. Then how many bits are required to represent each line? 3 bits. एक पेज में अगर 8 लाइन है, कितना बिट में एक लाइन को रिप्रेजेंट हो जाए? 3 बिट्स में. Can you tell me what is the page number and what is the offset? Quick answer. Very nice. 3 is the offset and this 5 is the page number. Yes or no? So how many pages are present now?
2 to the power 5.
2 to the power 5. सबको समझ में आ गया अभी? क्योंकि 2 to the power 8 नंबर लाइंस था, ईच पेज में अगर 8 लाइन से 256 by 8 कितना आएगा? 32. That is become 2 to the power 5 or not? Yes. So each page will be represented by 5 bits. If I create a normal page table, how many entries will be present in the page table? एक एग्जांपल सीख जाइए और कुछ नहीं चाहिए.
2 to the power 5.
2 to the power 5 entries होगा कि नहीं? So total number of entries should be 2 to the power 5. But what is saying? Why you are creating a very big 32 entry page table? Why don't you reduce it? So what he does? He divided this page number into 2 parts. जो 5 bits था उसको 2 पार्ट कर दिया. What is this? He is saying it is a 2 bit and this is become 3 bit. Then total become 5 bits. Like you can say the total address here is how many bits? Address of each line will be how many bits? 8. But 8 को कैसे वो divide किया है? 5 है page number, 3 है offset, उसको मिला लिया है. In the same manner, if my page number will be represented with a 5 bits, I can divide it into 2 and 3. Let's assume in this manner. If you can divide it into 2 and 3, now you tell me this 2 will be represented how many numbers? ये जो 2 bit होगा वो कितना नंबर रिप्रेजेंट करेगा? 2 bit. 4. अगर 2 bit में कितना नंबर रिप्रेजेंट करेगा? मैक्सिमम 4 bit, 4 नंबर. So what I can do? I can create a page table of 4 entries. Yes, and what should be the entries? 0 0 0 1 1 0 1 1. एक एग्जांपल सीख लीजिए, हो जाएगा. समझ पाए? मैं इसमें 2 बिट लाया एंड 2 बिट में 4 ही प्लेसेस रिप्रेजेंट हो सकता है, मैं ऐसे कर दिया. यस. When a page number comes as a 1 0 1 0 1, which page number it is? Quickly tell me. Which page number it is? If you can calculate it, this is 1, this is 4 एक 5 है, 5 ये कितना है? 8 ये 16, 16 5 21. 21 means 22 page. Yes, please come in. Is it correct or not? The 22 is my page number. But what it does, since I represented this as a 1 0, this 1 0 becomes what? This particular page. Yes or no? So if it is become how to come to this place, last class पढ़े थे. How you can come to a particular line of this page? First address किसको पता है? Page table base register. Then what I'll do? If my page table base register PTBR is written here, and this PTBR plus this 2 bits will be combined and come to this address or not? How much time it is required? Order of 1. If PTBR is known, order of 1. Now tell me, these 3 bits will be represented with how many? 8 such lines. Yes. So can I draw 8 such lines like this? 8 lines. So it is from 0 0 0 to 1 1 1. So like this, what will do? Why don't he will be remember this one? This will be remember another 8, and this will be remember another 8, and this will be remember another 8. थोड़ा space नहीं है इसलिए छोटा छोटा कर रहा हूँ. Yes. So what will happen? He remembers this, he remembers this, and he remembers this. Now what will happen? How many page table you have created? 5. So first page table में only 4 entries है, and it is a level 1 page table. Assume. And these are my level 2 page table. Level 2 page table में कितना page table होगा? इसमें जितना entries होगा corresponding to each entry 1 1 page table or not? And each page table के अंदर second level में how many entries are present? Since this will be represented by a 3 bits, now I can bring a 3 bits. So क्या लिखा होगा? I can say it will be written as a 209, it will be written as a 314, it will be written as a 156, it will be written as a 196. What does it mean? The base address of this is 196, the base address of this is 156. एक example सीख जाइए और कुछ नहीं चाहिए. 314 and this will become 29. किसको पता है? फर्स्ट लेवल पेज टेबल का वो एंट्री को पता है. ठीक है ना? नाउ व्हाट यू आर डूइंग? 10110. तो पहले क्या आया? PTBR will be added with 10. Then you come to this one, and what you are finding? You are finding the base address of what? 156. That is the base address of the third table. In third tables, which entry you are searching here? 101. 101 मतलब कौन सा entry है? 4 1 5. 5 मतलब 6 वाला entry. Yes or no? So if you can look into it, these are the number of lines. कौन सा entry में हमारा लिखा होगा? This will be become 101 and this will become sorry 101, 110 and 111 or not. So कौन सा entry में लिखा होगा? यहाँ पर कुछ entry में लिखा होगा. Yes or no? So what you can do now? This 156 जो आया, देख लीजिए, जो आया plus which one is coming? This is coming. This line number. If you can combine together, then you are coming to which line? That is 101 or not. समझ में आया थोड़ा बहुत? और एक बार बता रहा हूँ, हाँ? 101 है क्या? In this 101, what should be written? Total, how many entries are present in this second level? 8, 8, 8, 8. So कितना हो गया? 32. Previously, if you are maintaining a single page table, how many entries were there? 32. Now the exactly same 32 is coming or not? Now what you can get it? So this is added with 156. Come here and here exactly one frame's address will be written or not. If this is my RAM becomes, if you can consider this is my RAM, if your this particular page is present at this location, now if this location's address is let's take 10101, then I can say sorry 1011 like this, then here it will be written 10111 and this 10111 and this 3 bits here it will be present. What will be present here? 3 bits. If you can look into it, these 3 bits basically if you can look into it, then this is 3 bits. Suppose this 3 bits is how many 3 bits? Matlab 110. Then what will happen? This 3 bits comes here and this one will be combined and generate a address. This is the address where the instruction present. Are you getting it? So what you did? First, your whole logical address space is divided into 2 parts. One is the page number and another one is the offset. But what you basically do it here, this page number, if you are making a single one, then that will be a 32 entries are present. Instead of making it, what it does, he divided into 2 levels. So if it is become 2 levels, in the first level, he has kept 2 bits. In second level, he has kept 3 bits. So with the first level 2 bits, I can make it 4 entries. And with the second level 1, I can make this 8 entries. Then what it does, for the first level page table, only one page table will be present, but corresponding to each entry, second level page table is present or not. And in the second level page table, what is the offset is? The offset becomes 3 bits. If it is become 3 bits, how many entries are present? Total will be 8 entries will be present. Then once you get this 10 will be combined with PTBR, get this particular line. Here the base address of where it is written. The base address of the second level page table is written. So second level page table 156 is written. But this page tables, which line you are going, who knows? This 101 knows. And this 101 and this 156 combine and come to this location or not. And in this location, exactly what is written? The frame address where this particular page is present. So 10101 is present in which frame? 10110, and that's why it is being written. Yes. Now you can argue like this. One thing. If I'm maintaining it, how many total entries you are prepared now? 32 plus 4, 36. Why? Because these are the 8 entries, and this is become 4 entries. Total is 36. पहले तो बहुत अच्छा था. The previous one is become only 32. Now you are saying it is become 36. Then what is the better way? Can anybody tell me? Why you are using? Because to search this particular one.
Sir, वो ये हो जा रहा है.
To search this particular one, how many times the memory access is required? To search this particular one, how many times this memory access is required? Tell me quickly. No. How many times memory access is required if I want to execute this instruction? Quick.
Twice. The level होगा.
3 times. 3 times. Searching this particular one. This page table is also present in the RAM. This is first time. This page table is also present in the RAM second time, and instruction is present in the RAM third time or not. Now what advantage you are saying? All are disadvantage. Number of line 32 से 36 हो गया, and your number of access time also बढ़ गया. Previously 2 time access हो रहा था, एक पेज टेबल एक इंस्ट्रक्शन. Now 2 times पेज टेबल के लिए 1 time इंस्ट्रक्शन के लिए. Now it is become what? The total comes as a 3 times memory access. Then everything gets increased. But what is the benefit? The benefit is that instead of keeping the whole 32-bit page table, what I'll keep? Currently, since this particular page table is required, he will fetch this one along with this one. This and this is not required to bring it to the memory. समझ में आ गया? वो क्या क्या? Instead of bringing the whole 4 page tables, what he does, since he is using this particular page table currently, so he brought the first page table, along with this he has brought the second page table. So the total this and this page table means how many entries he has brought it? 4 plus 8, total 12. Out of 32, only 12 he has brought. It is benefited or not? If your RAM size is too less, then this will be more beneficial rather than this. And no paging. If you go to a real environment, nowhere a single page table is maintained. Every time a multi-level paging is maintained. Yes, ask. Oh, come to that point. So first what you have learned? First we have learned that by this way we have reduced the number of entries, bring it to the memory gets reduced. Previously whole page table is brought to the memory. Now only part of the page table is brought to the memory. Now somebody asks, sir, a part of the only memory kam khaya, but everything else is more. The time requirement is more, everything gets more. Can you reduce the timing here? What to do? You can use a TLB. So what is the TLB here? If you can look into the TLB, once you find this particular frame address, why don't you update in a TLB? Once you update in the TLB, what is the TLB access time? एक बार TLB में सर्च करेगा, डायरेक्टली मेमोरी को आएगा. बट यहाँ पर क्या है? फर्स्ट लेवल पेज टेबल एक बार, सेकंड लेवल पेज टेबल एक बार, इंस्ट्रक्शन एक बार. Always 3 times or not? Yes or no? But if you can introduce in a TLB, it gets reduced. Idea थोड़ा आ गया? I am drawing now the whole figure once again so that you can get the idea. Yes. So what is the figure? Because figure भी चाहिए आप लोग को. हाँ. Where? This page table is already present in the memory. Yes. When it will be brought to 1 second. हाँ वो बोल रहा हूँ, वही ड्रॉ करके ही बोल रहा हूँ, कहाँ पे लाएगा वही बोल रहा हूँ, ड्रॉ करके. Okay, so let's assume that this is my page table, logical address space. Logical address space में आपका 3 लेवल है. Now question answer के लिए रेडी हो जाइए. So this is my offset D, this is my level 1, this is my level 2, this is my level 3. I make a 3-level paging. Okay, so if it is a 3-level paging, in first level there will be this. In second level, there will be many such pages. थोड़ा सा वेट कर लीजिए, 1 मिनट आपको वेट करना पड़ेगा. 1 मिनट में थोड़ा ड्रॉ कर लेता हूँ, उसके बाद आपका आंसर. हाँ, okay. This, then I'll make the second level page tables. Then it is a 3rd level page table also present. Yes. Then there is a TLB present. Yes, and this is your RAM present. Yes, this is our RAM. So what it does, first your PTBR is there. This PTBR will be added with whom? First level this. Then it will come where? This is coming, then it is come to 1 entry. Yes, each entry of this is remembering what? The second level space table. So इसमें क्या होगा? Suppose he is remembering this particular address, then indirectly आप क्या करोगे? this, suppose he is remembering this particular address, then if you want to add it, then this thing plus, tell me, the second level page table is coming. Now it is come to this one. Once you bring it to this one, then here who is remembering what? This, he is keeping the third level page table. So suppose, let's assume that he is remembering this particular page table. Then you are bringing this and you are bringing this. Yes, then you are getting somewhere here. Once you get it here, then what he does? He is keeping this address and keeping this address here. Normal way or this or not? So kitna level abhi kabe without TLB? Without TLB kya kya? So first level dhunda, first level PTBR is remembering this address, this plus this one. Suppose it is a 01, this is 101, this is a 01, then it will be 11. Then what does it mean? This 01 will be added with the PTBR. Come here. He is remembering this address. This plus 101 will be come to this. Yes. Once you commit, he remembers this particular address, but I want a particular frame. Then you add it with this L3. Once this L3 combined, I got this frame address, and this frame address and this offset combined, I got it. Yes. Then his question is when it will get updated. The moment you get this frame address, it is which page frame address? As per this example, this frame address, suppose the frame address is 1110011. This is whose place frame address? Tell me please. This is 01100101's frame address is 111011 or not? Why? This is my page number or not? This page number ka frame address kya mila? 111011, and this is, once you got it here, can I update it here? 011011 01, no? Say kya? Then this is page number is frame number is what? 111011. When second time I search for a, instead of 11 I search for a 10, can you go for searching this or better to find in a TLB? Page number is same, only what is changing? The offset is changing. Since it offset is changing, so I can directly say it has to be searched in this TLB. Yes, the moment is find it, then what will happen? Now it will go to this frame address. Once you get this frame address, undo this. So how many times TLB access has made? For this, the TLB access has only once. Why? Because first time he is accessing the TLB. If it is found, directly come here and get this instruction or not. Then what is the time it is coming? This time plus one memory access time. But if he is not finding it here, then what he has to do? He has to be access this one, this one, this one, and this plus this not find. Yes or no? Can anybody tell me in 3-level paging what is the effective access time? Quick. Effective.
वो 3 times होगा.
Yes.
So
yes, if your TLB access time is, let's take gamma, and your hit ratio, this hit ratio is become let's take alpha, then what should be the effective access time? And memory access time is beta. Memory access time is beta. Memory access time is beta. Then how much is coming? Hit ratio boliye, alpha into something plus something into 1 minus alpha. Yes or no? So tell me, in case of hit case, what you are searching? Please tell me. If it is found it here, you are searching once TLB and one instruction. So kitna hua?
Gamma plus beta.
Beta plus gamma. Yes or no? But if it is not found, then what you are doing? Once you are finding gamma, not found, then 1, 2, 3, 4 betas. So you can say it is become 4 beta plus gamma. No need to remember anything. Just by this you can do it. समझ में आया? एक बार उसको मिल जाने के बाद he can now update it in the this TLB and access it. Understood? So what is the benefit? Now with the help of the TLB, I reduce two things. I reduce the size of the page table which is brought to the memory with the help of what? Multi-level paging. Along with the TLB, I reduce the fetching time. But if I don't use the TLB, somebody told the time requirement is too high. Because 3 बार access करेगा मतलब 20 times सोचिए बहुत time है. But once it is updated in the TLB, no required to do it. Okay? Yes. So that is the idea. So let's. I'll give you some hints. Now you have to tell me. Suppose my page table is like this. Can anybody tell me now quickly what is the logical address space size? Quick answer. What is the logical address space size? 2 power? Logical address space size. Huh? 2/7. Very simple. अरे logical address space मतलब क्या है? जितना logical address है, that is 2 to the power this. So 2 3 5 2 7 9 कितना होगा? 2 to the power 9. Number of page table कितना है? Number of pages कितना है? The number of pages is 2 to the power 7. समझ में आया? The number of pages is 2 to the power 7, whereas my logical address space is become 2 to the power 9. हो गया? Yes. अभी बोल पाओगे? Total number of page tables present in this whole system. गलत बोल नहीं बोलोगे. Total number of page tables present here. पीछे को देख लीजिए, आप तुरंत कर पाए. पीछे में कितना था? Total number of page table कितना था? अगर क्वेश्चन पूछा जाए, in this case. अरे 1 2 3 4 5 पेज टेबल था. लेवल 1 में 1 था, लेवल 2 में 4 था, है कि नहीं? लेवल 1 में 1 एंड लेवल 2 में. कभी लेवल 1 में मोर देन 1 हो सकता है? कभी भी नहीं. इन ए लेवल 1 पेज टेबल कैन इट एवर मोर देन 1? नेवर. बट लेवल 1 पेज टेबल पॉइंटिंग टू whom? Level 2 page table means is indirectly a tree structure or not? If you can consider this is my root node, this root node has how many children? 4 children. Like this, can you guess it here? Then in each level of this, how many children are present? सोच के बोलिएगा, नहीं तो पूरा पिटा ही होगा. Each level पे बोलिए. 0th level पे कितना nodes हैं? 0th level पे एक root है. And who is that root? This fellow is the root. Tell me second level में कितना है? सेकंड लेवल पे
2 to the power 3 क्योंकि 101 है.
सेकंड लेवल पे कितना नंबर ऑफ पेज टेबल है? सेकंड लेवल पे कितना नंबर ऑफ पेज टेबल्स है? टेबल्स 4. अरे इसमें कितना एंट्रीज होगा? 0 1 है मतलब कितना एंट्रीज होगा? 4 एंट्री.
2 to the power 2.
समझ पाए कि नहीं? ये अगर 2 बिट है कितना एंट्रीज होगा? 4 एंट्री. लाइक 0 0 0 1 1 0 1 1. Each entry will be pointing to 1 1 second level page table or not? समझ में आया कि नहीं? अगर ये इतना है, आप अभी बोल पाओगे तो कितना नंबर ऑफ यहाँ पर पेज टेबल होगा?
8.
It is 4. अरे एक पेज टेबल 4 पेज टेबल. ओके. सो इसमें कितना आया? 1 पेज टेबल. इसमें कितना आया? 4. इस यहाँ पर
8 हो जाएगा.
नहीं बोल पाओगे तो यहाँ बैठ के खुद को थापड़ मारोगे. वो लोग मार रहे हैं कि नहीं पता नहीं. कितना? 8. 16 32.
सर एक का तो 8 होगा. एक
मुझे पता नहीं है,
4 करेंगे.
गिनती मुझे नहीं आता है.
32 हो जाएगा तब. 8 into 4 हो जाएगा.
8 into 4 32 कोई बोल रहा है. हाँ. यहाँ पर कितना नंबर ऑफ पेज टेबल्स है? 4. ईच पेज टेबल में कितना एंट्रीज है?
8.
क्योंकि 3 बिट है मतलब 8. तो एक पेज टेबल का कितना सब पेज टेबल होगा? 8. सो इसका 8, इसका 8, इसका 8, इसका 8, टोटल कितना हुआ 30। नहीं समझ में आया? समझ गए ना? बिकॉज टोटल नंबर ऑफ पेजेस यहाँ पर कितना है 4। अगर ऐसे ड्रॉ करूंगा, आपको डाटा स्ट्रक्चर ज्यादा आता है इसलिए बोल पाओगे। इसमें कितना एंट्रीज है 4। क्यों हमारा पेज टेबल क्या था 2 बिट का, 3 बिट का, फिर शायद 2 बिट का, ऑफसेट था 3 बिट, मतलब पेज नंबर हमारा इतना है। सो 2 बिट मतलब 00, 01, 10, 11। इसमें हर एक में कितना एंट्रीज होगा 1-1। सो इसमें 1, इसमें 1, इसमें भी 1, इसमें 1 है कि नहीं? हर एक में कितना है 3 बिट का, 3 बिट मतलब कितना होगा 8 एंट्रीज। समझ पाए? सेकंड लेवल पे 8। सो ईच एंट्री के लिए एक का पेज टेबल होगा कि नहीं? यस, लाइक दिस। सो टोटल यहां पर कितना, यहां पर 8, यहां पर भी 8, एंड हियर आल्सो 8, हियर आल्सो 8। सो टोटल 32। समझ पाए? यस, कोई बोलेगा तुरंत, are you getting? Yes. So like this you have to sort out in this. Suppose somebody will quickly tell my page table has this division. This is 2 bit, 4 bit, 6 bit, 2 bit, and 3 bits. Can you quickly tell me what is the total number of page table? Quick answer. Total number of page table. Quick answer. Total number of page table. शॉर्टकट आप लोग फाइंड आउट करो, मुझे पता नहीं है। 2 टू पर हाँ हाँ क्या करूंगा पहले 2 टू द पावर 2 प्लस 2 टू द पावर 2 इंटू एक दिन भी आना चाहिए। कितना इंटू 2 टू द पावर 4, ओके, प्लस 2 टू द पावर 2 इंटू 2 टू द पावर 4 इंटू 2 टू द पावर 6 प्लस, वेरी नाइस, 2 टू द पावर 2 इंटू 2 टू द पावर 4 इंटू 2 टू द पावर 6 ये ऑलरेडी हो गया है हमारा काम। ए कितना होगा इसमें, देखिए इस लेवल पे कितना आया, फर्स्ट लेवल पे कितना वो कैलकुलेट नहीं किया 1, फर्स्ट लेवल इज 1, सेकंड लेवल पे फर्स्ट लेवल पे 1 हो गया, सेकंड लेवल पे दैट इज 1 मोर वी हैव नॉट एडेड, दैट इज 2 टू द पावर 2, यस और नो, देन 2 टू द पावर 2 इंटू 2 टू द पावर 4, देन 2 टू द पावर 2 इंटू 2 टू द पावर 4 इंटू 2 टू द पावर 4, तो लेवल हो गया। ये क्यों चाहिए?
2 to the power 2
हो गया कि नहीं? This is what you are saying. What is this? Can anybody tell me? He is saying 2 to the power 2 into 2 to the power 4 into 2 to the power 6 into 2 to the power 2. What is this?
हाँ वो तो फिर वो हो जाएगा।
Quick answer.
Lines in the last.
The number of lines present in the last level. Why? What is the total? The total is nothing but was it 2 plus 4 6, 6 plus 10, 10 plus 14. 14 means it is 2 to the power 14. Do you think that what is the total number of page size? 2 plus 4 6, 6 plus 3 14, मतलब कितना नंबर ऑफ पेजेस होगा 2 to the power 14 नंबर ऑफ पेजेस होगा। टोटल एंट्री कितना चाहिए 2 to the power 14 एंड द सेम 2 to the power 14 प्रेजेंट। समझ में आ गया? ऐसे ही क्वेश्चन पूछेंगे आपको लेके कि ये करो, ठीक है? इसका लेवल कितना है 4 लेवल ना, एक लेवल का है, 2 लेवल, 3 लेवल, 4 लेवल, ये मेरा ऑफसेट डी कि नहीं? 1 का पहला जो रखेगा, आप जो बोले 2 बिट का है 01, तो फर्स्ट टेबल में क्या रहेगा 00, 01, 10, 11, करेक्ट नहीं कि नहीं? ये आप गिनती कर लिए कि ये मेरा पहला पेज टेबल है, ये तो नहीं है ना। इसके हिसाब से आप अगर देखेंगे तो हमारा फर्स्ट पेज टेबल में नंबर ऑफ एंट्रीज है 4, बट पेज टेबल कितना है, एक ही है कि नहीं? यस, समझ पाए? यस, अगर ये समझ पाए थोड़ा सा क्वेश्चन करते हैं। हाँ, we have another 15 minutes. I hope you'll enjoy this questions. एक एक करके सॉल्व करते हैं. This माइंड कोर्स OS.
सर तो इसका आंसर क्या होगा? वो
आंसर क्या होगा? जितना ऐड कर दोगे वो मैं कैलकुलेट नहीं करूंगा.
सर वो 2 to the power 2 to the power
1 plus this plus this plus this.
ठीक है सर.
ओके, जितना आएगा वो हमको कैलकुलेट करना. ठीक है ना
सर? इसको रिप्रेजेंट करने के लिए b+3 यूज होगा
यूजुअली. इसको वो पूछ रहे हैं कि इसको रिप्रेजेंट करने के लिए कौन सा टाइप का ट्री यूज होगा. ए जनरल ट्री, नॉट इवन द B+3.
ओके सर.
Okay, but as for why you are saying B+3, what is the difference between B+3 and every tree?
सर इसमें नंबर ऑफ चिल्ड्रंस वेरिएबल है.
All the leaves has to be present in the same level, which is not happening in the BST or every tree. Yes or no? And here if you can look into it, the same thing is happening. B+3, B tree and B+3 में क्या difference है? सब भूल गए. जब
वो नंबर
तो क्या B tree क्या है? In case of a B tree, all the elements may not be present in the leaf node, whereas in case of B+3, 3 element must be present in the leaf node, and all the leaf nodes should be connected with one to next. याद है? आप भूल गए, सब भूल गए. बी ट्री में क्या होता है? 5 4 3 2 1 7. इसका 2 3 बी ट्री बनाएंगे तो कैसे करते हैं? 4 फिर 5 फिर 3 आया, 3 आने पर क्या हो जाता है? 4 फिर
स्प्लिट हो जाता है. हाँ,
फिर 2 आया, 2 हो गया, फिर 1 आया, फिर 1 जब आएगा तो 2 स्प्लिट हो जाएगा. then it is become 2 4, then it is become 1, then it is become 3, then it become 5, then 7 आया, 7. This is the B. But if you can make the same data with the B+3, so 5 आया, 4 आ गया, फिर कितना आया? 3. 3 मतलब क्या होगा? What is saying? 4 goes top, but 3 4 will be present here, 5 will be present here, and there is a link between this. So all the elements present in the leaf node. Once again comes 2, so 2 will become here, then 3 will be go up. When it will go up, 3 4 comes here, then it will be become 2 3, then it will be become 4, then it will become 5. So now this is link. So what happens here? 2 3 4 5 all are present in the leaf node. Once again comes the 1. 1 कहां पर जाएगा? 1 यहाँ, फिर क्या हो गया? 2 यहाँ आ गया, 2 यहाँ आ गया तो कौन ऊपर जाएगा? 3 ऊपर चला जाएगा. तो क्या होगा? So this will be become 3, 3 will be become 2, 2 will be become 4. This has 2 parts, this has 2 parts. 2 has divided, it is become 2, this is become 3, this is become 4, this is become 5. So 1 2 3 4 5. Then hope 7 you can. Yes, it is not a graph, but it is like this. Okay, I hope we will not discuss a lot now, because this is a different class. Now the questions are like this. First questions, let's see, one by one we'll do it. Don't be hurry. Okay, question number 1. Everybody is able to read? Yes. थोड़ा zoom. Okay. कीजिए जितना कर पाते हो, बस ड्रॉ कीजिए, देखते हैं कितना आता है. वो प्रॉब्लम नहीं है, आएगा, मैं इसीलिए नहीं दिखा रहा. आई विल सॉल्व इट, बट हाउ मच यू आर गोइंग, दैट आई वांट. (36-bit virtual address space with a page size of 8K, 4 bytes per page table entry, and how many pages are in the virtual address space? What is the maximum size addressable physical memory? RAM पूछा है और लॉजिकल एड्रेस स्पेस पूछा है कि नहीं. कितना डायग्राम ड्रॉ करना आता है? तो हमारा 4 है कि नहीं? लॉजिकल एड्रेस स्पेस, लॉजिकल एड्रेस, पेज टेबल, रैम.
सर 4 बाइट्स क्या है इधर? पेज टेबल एंट्री मतलब वो तो नंबर ऑफ पेजेस होगा।
ईच पेज टेबल एंट्री में 4 बाइट्स है।
ओके ओके।
ईच पेज टेबल का जो एंट्री है वो 4 बाइट का है।
यस सर।
टीएल भी आप जल्दी कर पाओगे, ये थोड़ा भूल गए हो शायद। हाँ, so I'm just drawing the figure. I hope you can participate. This one, and this. सिंपलेस्ट way. क्या क्या दिया है पहले फिल कर लीजिए, बोलिए। 36 बिट वर्चुअल एड्रेस कौन सा फिगर में आएगा? 36 बिट कहां पर? यहाँ पर है कि नहीं? 36 बिट मतलब 36 बिट वर्चुअल एड्रेस है 36 बिट, ठीक है ना। एंड एड्रेस स्पेस दो पार्ट होगा, छोड़ दीजिए। एंड एड्रेस स्पेस 36 बिट वर्चुअल एड्रेस स्पेस। सो टोटल लॉजिकल एड्रेस स्पेस कितना होगा? वेरी नाइस, 2 to the power 36। क्योंकि 36 बिट का अगर एक एक एड्रेस हुआ, टोटल साइज कितना होगा? 2 to the power 36। अभी विथ पेज साइज 8K, पेज साइज कितना है? 8K मतलब 2 to the power कितना बोल लीजिए? 13। सो ये अगर 13 हुआ, ऑफसेट हमारा कितना होगा? 13। ये अगर ऑफसेट 13 हुआ, ये कितना होगा? क्विक 23। सो नंबर ऑफ पेज टेबल कितना आ गया? पेजेस, नंबर ऑफ पेजेस, वेरी नाइस, 2 to the power 23। नंबर ऑफ एंट्रीज कितना आ जाएगा? 2 to the power 23। इफ 2 to the power 23 रहेगा, ईच एंट्री में क्या है? 4 बाइट्स पर पेज टेबल एंट्री। ये है 2 to the power 2 का। सो टोटल कितना हो जाएगा पेज टेबल साइज? 2 to the power 23 into 2, that is 2 to the power 20। कि नहीं? और क्या पूछा है? हाउ मेनी पेजेस आर प्रेजेंट इन द वर्चुअल एड्रेस स्पेस? है तो हो गया। कितना?
रैम का साइज पूछा है।
हाँ, हाउ मेनी पेजेस आर प्रेजेंट? दिस मच। ओके, नाउ टेल मी व्हाट इज द वर्चुअल एड्रेस स्पेस?
वर्चुअल एड्रेस स्पेस कौन सा है? ये वाला तो रैम वाला तो
रैम वाला वर्चुअल एड्रेस स्पेस तो हम कैलकुलेट कर दिए। रैम वाला एड्रेस कितना होगा? रैम का
2 to the power 32।
फ्रेम साइज इनटू नंबर ऑफ फ्रेम्स। फ्रेम साइज कितना है? 13, क्योंकि पेज साइज इज इक्वल टू फ्रेम साइज। नंबर ऑफ फ्रेम्स कितना है?
2 to the power 32।
4 बाइट साइज में तो
48 होगा।
कितना है? 4 मतलब कितना बिट है? 32 बिट। मतलब ईच एड्रेस 32 बिट का है। सो कितना ऐसा होगा फिर? 2 to the power 32। सो टोटल कितना हो गया? 2 to the power 32 into 2 to the power 30, जितना आया। Got it? हाँ, एक चीज पूछे। नो, यहाँ पर 36 बिट का वर्चुअल एड्रेस दिया है, एड्रेस स्पेस नहीं दिया है। ये एड्रेस स्पेस 36 बिट वर्चुअल एड्रेस स्पेस मतलब क्या है? मतलब एक एक एड्रेस है 32 बिट का, 36 बिट का। समझ पाए? यस, 36 बिट का कभी आपका टोटल एड्रेस स्पेस होता है क्या? 36 बिट वर्चुअल एड्रेस स्पेस मतलब आप एक एक एड्रेस है 32 बिट का, 36 बिट का। ठीक है? यस, ओके, नो प्रॉब्लम। नॉट
32 कैसा है?
यहाँ पर 32 कैसा है? ए वाला,
हाँ,
ए वाला दिया है ना, ईच पेज एंट्री 4 बाइट्स बोल के दिया है।
हाँ, तो
4 बाइट मतलब 32 बिट्स है ना।
ओ बिट्स,
समझ है ना? 4 बाइट्स मतलब ईच एंट्री में यहाँ पर कितना बिट लिखा होगा? 32 बिट। ये जो बिट लिखा है वो किसका एड्रेस है? ये ईच फ्रेम का एड्रेस है। अगर ईच फ्रेम का एड्रेस 32 बिट हुआ तो कितना ऐसे फ्रेम होगा? अगर ईच फ्रेम एड्रेस 3 बिट का हुआ, ऐसे कितना फ्रेम होगा? 8। सिमिलरली इफ इट इज 32 बिट, कितना होगा? 2 to the power 32 ऐसे फ्रेम होगा कि नहीं? And each frame size 2 to the power 13, it is become like this. Okay? Yes. So one more last question we'll do. TLB नहीं करेंगे, बाद में करेंगे, क्योंकि TLB आज पढ़े। ये कर पाओगे? ये बहुत इंटरेस्टिंग क्वेश्चन है। Consider a single level paging scheme, मतलब एक ही पेज टेबल, हाँ? It is not multi-level paging. Okay? And saying the virtual address space is 4 GB. ओके, सो ड्रॉ कर लेते हैं हम 4 फिगर। बस प्लेस कर दीजिए, देखिए जल्दी जल्दी हो जाएगा आपका। हमारा कंसीडर लेवल, एक लेवल का पेजिंग है, वर्चुअल एड्रेस स्पेस 4 GB, ये है 4 GB। अभी देखिए 4 GB मतलब पूरा एड्रेस है। 4 GB मतलब कितना है? 2 to the power 32 मतलब हमारा लॉजिकल एड्रेस कितना होगा? 32 बिट का। वेरी नाइस, हो गया हमारा। यस, नाउ नेक्स्ट पेज इज दिस, एंड पेज साइज कितना दिया गया है? 128 KB। दिस इज द इजीएस्ट वन। ओके, हाँ, कितना होगा? अरे 128 बिट KB है। 128 KB मतलब क्या है? 2 power 17, मतलब ये 17 हो गया कि नहीं? If it is become 17, how much it is? 50. So हो गया। Then बोलिए, what is the easiest one? What is the maximum page table entry size possible such that entire page table fit well in one page? Very interesting question. फिर से और एक बार देखिए, इतना तक सबको समझ में आ गया? 4 GB का है लॉजिकल एड्रेस स्पेस, 128 का इतना था। वो बोल रहा है कि व्हाट इज द मिनिमम पेज टेबल एंट्री साइज, ईच एंट्री में कितना बिट्स होगा, सो दैट सच दैट द एंटायर पेज टेबल विल बी फिट वेल इन वन पेज। एक ही पेज में पूरा पेज टेबल फिट हो जाएगा।
इसका मतलब कि पेज टेबल साइज इज इक्वल टू वन पेज साइज।
वेरी नाइस। इसका मतलब है the whole page table size should be 2 to the power 17। वो पूछा है ऐसा, एक क्वेश्चन ऐसा पूछा है कि व्हाट इज द क्वेश्चन पूछा है व्हाट इज द मैक्सिमम पेज टेबल साइज, पेज टेबल एंट्री साइज पॉसिबल सच दैट द एंटायर पेज टेबल विल बी फिट इन वन पेज। मतलब वन पेज मतलब कितना है हमारा? 2 to the power 17। मतलब यहां पर कितना ऐसे बीट लिखोगे, वो पूछ रहा है, यहां पर कितना ऐसे बीट लिखोगे जो कि पूरा पेज टेबल 2 to the power 17 हो जाएगा?
पूरा आएगा?
ये शायद 9th क्लास मैथमेटिक्स, इससे ज्यादा नहीं होना चाहिए।
क्या वो फॉर्मूला में लिखने के बाद वो
वेरी सिंपल, व्हाट इज सेइंग, यू नो, यू आर लिसनिंग वंस अगेन। वो बोला है कि व्हाट शुड बी द एंट्री ऑफ दिस सो दैट माय टोटल पेज टेबल का साइज एक पेज होगा। एक पेज मतलब कितना है? 2 to the power 17। सो ये टोटल पेज विल बी 2 to the power 17। टोटल पेज कैसे कैलकुलेट होता है? टोटल पेज टेबल कैसे कैलकुलेट होता है? नंबर ऑफ एंट्रीज इनटू ईच एंट्रीज। ऐसा लो, कितना नंबर ऑफ एंट्रीज यहां पर है? क्विक आंसर, वेरी नाइस। यहां पर 2 to the power 15 एंट्रीज होगा कि नहीं? सो आप बोलोगे सर 2 to the power 15 एंट्रीज इनटू कुछ करेंगे जो कि 2 to the power 17 होगा, सही कि नहीं? सो ये क्या है? ये 2 to the power कुछ x होगा। Then what you should do so that it will become 2 to the power 17?
2 to the power 2.
That is become 2 to the power 2. So इसका साइज कितना होगा फिर? 2 bytes। मतलब अगर each page entry size 2 to the power 2 हुआ, then it will become fit into one page. Then can you tell me what is the RAM size? Quick, RAM size What is the RAM size, maximum RAM size in this case?
2 to the power 17 into 4.
2 to the
4.
2 to the power 16 into 2 to the power 17. Is it correct? Yes, sir. Thank you very much. Because this 2 bytes says that each frame का जो address होगा 2 bytes, मतलब 16 bit, and page table already given 2 to the power 17. Total कितना? That's okay. Next class, few more we'll do. Then we'll go to the next. That's all. Okay, I'm ending now. Ending the meeting. थोड़ा सा प्रैक्टिस कर लीजिए. There are many